Hello class, and welcome back to the last piece of solving linear systems. This is chapter 7.3, solving linear systems by linear combinations, or which I call elimination, and which I find to be the one that I would choose to use the most. You can form your own opinion between graphing, substitution, and elimination, but I think after a while this might be the easiest method. So let's look at the steps. There are quite a few steps here, but they will come together to make sense. So the first one is to arrange the equations with like terms in columns. So what that means basically is this. We want to make sure that before you can start to solve a problem, that they are in standard form. So that's what step one is saying. That arrange the equation with like terms in columns. So we have our columns here, ax plus by equals c and ax plus by equals c. So first step, make sure that they are in standard form. Step two, you're going to multiply one or both of the equations by a number to obtain coefficients that are opposites from one of the variables. Now, this may occur, step two here. Okay? Step two, the problem already might give you that step to accomplish, and we will talk about that. Alright, so what I'm saying is we may skip this step depending on what the problem looks like, and I'll show you that in 1 second. But step three here, add the equations from step two. Combining like terms will eliminate one variable. Solve the remaining variable. So you'll see that, and then substitute the value obtained in step three into either of the equations of the original equations. Okay, so once you get that answer, you want to plug your solution back into one of the original equations to get the other variable, and check the solutions in each of the original equations. Okay, a lot of checking in this chapter. So let's go through each step and I'll show you. So here we go. We have 4x plus 3y equals 16 and 2x minus 3y equals 8. So we have two standard form equations. Okay, so step one is done. They're in standard form. Step two says to multiply one or both equations or variables if needed. Okay, remember I said if needed. Step three really says to look and see if you can add down right now, and would it eliminate a variable. So again, let's rewrite this, and I'm going to ask you, could we add down right now and it would eliminate a variable? And the answer to that would be yes. If I added 3y plus a negative 3y, they would cancel each other out. That would give you 0. So if we added down, we'd be left with 6x equals 24 divided by 6, and x equals 4. So again, we're trying to find our ordered pair here. And it says, okay, we're going to plug this 4 back in into any of the original variables. So you could choose, or equations, I'm sorry. So you could choose either equation 1 or equation 2 to find out what y equals. So I'll plug it into the second one here since I drew an arrow there. 2 times 4, because I'm plugging 4 in here for the x value, is 8. 8 minus 3y equals 8. Subtract 8 over. I get negative 3y equals 0. And then y equals 0. So now to check this, you're going to plug them both back into the original equations just to verify. Here we go. 4 times 4, because x is 4 over here, is 16. 16 plus 3 times 0 is 0, so that equals 16. So that's a check. 2 times 4 is 8. Negative 3 times 0 is 0. So 8 minus 0 is 8, which checks out. Okay? So in going back to the steps, it's almost like you want to look at this one second. Okay, that's step 3. Second, just to see if you can add the equations down. Now, if you can't add them down, then you have to perform step 2. So make sure you take a look and see if you can add down to make that happen. And I was able to add down here because they canceled each other out. Okay. So let's rewrite this. 3x plus 5y equals 6, and negative 4x plus 2y equals 5. Okay, so I wrote them both in standard form. Step 1's complete. Okay, now look and see if you can add down. If I added down right now, would one of the variables cancel out? So 3 plus a negative 4 is negative 1x. 7 plus 2 is 7y. So a variable would not cancel out if I added down. Let's see if I can get that. There we go. There we go. So now we go back to step 2, and it says multiply one or both of the equations by a number to obtain coefficients that were opposite. So there's two ways you could do this. Okay. Now you want to look at coefficients that are opposites. So 3 and negative 4. That's a positive 3 and a negative 4. To get my x's to cancel out, I'm going to multiply this by a positive 4. I'm going to multiply the bottom by 3, and I'll show you why. When I distribute this 4 to everything inside the parentheses, I get 12x plus 20y equals 24. And on the bottom here, I get negative 12x plus 6y equals 30. So these cancel each other out now. And then I'm left with 26y equals 54 divided by 26, y equals 2. So I'm going to plug 2 back into one of the equations to find out my x. But again, let's go back. Let's refresh this now. So if I added down right now, nothing would cancel out. Okay, that's what I want to look at. Could I add down, something cancels out? Nothing cancels out. So I'm going to look to multiply. Okay, I could multiply just one of these by something if I knew that it would still be the opposite of the other equation. Because remember, my goal is to get a variable to cancel itself out, so I'm only left with one variable. Okay. So knowing that I couldn't just multiply the second equation by something, I had to multiply both of them by something. Okay. Then I look at what's basically the easiest two numbers I can multiply by so that we do have an opposite. Okay, so I always look for a plus minus because I know those are opposite. Let's look at those coefficients and see what their least common multiple is there. Okay. So let's go back. We have y equals 2. Let's plug that back in. We know that 2 times 2 is 4. Subtract 4 over. We know that's 1, so negative 4x equals 1. Divide by negative 4. X equals negative 1/4. So what is 3 times negative 1/4? I can tell I already did something wrong because this isn't really gelling, and I can already see my mistake. 3 times 5 is 15. This should be a 15. 15. 6, that's right now. Okay. So add that together. Let me erase this real quick. I'm sorry. So just double checking my information here. 26y equals 39 divided by 26. You get 1.5. If I take a 13 out of both of these, left with 3 over 2. So I apologize. Got 1.5. So 1.5, plug that in now. We know that you can plug it back into any of the other equations. Either one would work. So 1.5, let's do the top one, times 5 is 7.5. equals 6. Subtract that 7.5 over. You get a negative 1.5 and divide by that by 3, and you get negative a half, or negative 0.5. So let's check this out. We know that negative 4 times a half is 2. 2 times 1.5 is 3, and 2 plus 3 equals 5. That does check out. This is the right solution. So I apologize. That was a disaster problem by your teacher. So slowly go back through it, and you can see that's why you got to really make sure that you really watch your work. Obviously, when I distribute this 3 to everything, I moved extremely fast and put 30 instead of 15. So forgive me. Let's move on to the next question. So here we go. 3x plus 2y equals 8. 2y equals 15 minus 5x. So let's move over this negative 5x. Let's add it over. Because remember, we want to start in standard form. Okay, so here we go now. We have 3x plus 2y equals 8 and 5x plus 2y equals 12. Now, remember I said before, look and see if you can add down to get rid of a exponent, or a variable, sorry, and you can't. Okay, we'd have 8x, we'd have 4x on the left side of the standard form equation. So can I multiply one of these equations by something that would give me an opposite, okay, of one of the other coefficients? If I multiplied this top one just by negative 1, this would give me negative 3x minus 2y equals negative 8. So there we go. We have opposites right here. So we can add down now, and these would cancel out, so you're left with 2x equals 4. Divide by 2, x equals 2. Plug 2 back into one of the original equations. So I'll plug 2 back into the top. I got 6 because I plugged 2 times 3 is 6, plus 2y equals 8. Divide or minus the 6 over. You get 2y equals 2. Divide by 2, y equals 1. Plug it back in here to check. I know that 2 times 5 is 10. 12 minus 10 is 2. And 2 times 1 is 2, so 2 does equal 2. Alright, so remember, this is just an introduction. Go through here again, really look at and examine these steps and know them so we can talk about them in class. Really look at first, can I add down? Make sure it's in standard form first, then look and see if you can add down to eliminate one of the variables. And if you can't add down right out the bat to eliminate a variable, then you're going to have to multiply one of the variables by a number so that the coefficients of one of the variables are complete opposites so that you can cancel them out. Okay, so then I get to this step, you find out what x equals, and then plug that x back in. And then check it in both equations, okay, to verify. Alright, here's your homework. Kind of set up just like the problems I gave you. Problem 1, 2, and 3. Make sure that they're in standard form again. Look at first and see if you can add them down after they're in standard form. And if you can, make that move. And if you can't, then you got to multiply one or both variables or equations by another number. Alright? So, hope you enjoyed this video. Sorry it's taken us to the 15-minute mark almost. There's a lot of information in this. Try these problems. Try each one. If you have any questions, email me. If you have any questions tomorrow, we'll get it taken care of in class. We have plenty of time to get this material ingrained in our brain. So don't worry if for some reason after this video you still feel lost. It's okay. We'll take care of it. Hope you have a wonderful night, and I'll see you tomorrow in class. Take care.